So yeah, hello everyone. Welcome to GeeksforGeeks Python channel and in Python interview preparation course as well. So we started this course like series of lectures named Python interview preparation course with the aim of provide the best Python interview, okay, for the freshers. So if you are someone who are in your final year and looking for some best Python resources or any like any programming language, and if you are starting right from the basic, and this particular video or lecture is for you, okay. And we have covered till 7 lessons, okay. We started from history of Python to now we are discussing problems on loops, okay. So yeah, if you are watching this stream, please don't forget to hit that like button, okay, and please let me know in the comment section as well. So if you like this session, please let me know in the comment section. So someone who is visiting the video for the first time, they will get to know what kind of content it is, okay. So yeah, let's get started, okay. So before starting, myself Vamsi, so currently working as an associate software engineer at SNS Hyderabad. So that's pretty much about me, okay. Yeah, so a quick recap of what we have seen yesterday. So nothing much, it's all about problems, okay. And really I didn't remember what are all the problems that we have solved, but it was around 6 to 7, I guess. 6 to 7 problems, okay. So if someone has attended previous class, please let me know what are all the problems that we have discussed yesterday. And today also it's the same, okay. We will be solving few more problems using Python. Yep. So yeah, let's start. So the very first problem that we are going to discuss today is actually I'm just continuing where I have stopped yesterday, okay. So I guess I have the last problem that I have discussed yesterday was palindrome. Yesterday means it's an L7, okay, lesson number 7. If you haven't watched, please go and watch that as well. So I have solved a bunch of problems over there as well, okay. So the very first problem that we are discussing today is Armstrong number. And if you know what is Armstrong number, please let me know in the chat, okay. So if you don't know, it's okay, I'm here to help you, right? Yeah. So the Armstrong number is a number where the power of the number of digits of a given number, the summation of all those things is called an Armstrong. Like let's say I have given you an n, okay, where n is 1 2 3, okay, 1 2 3. So let's say if I wanted to show this a number as a Armstrong number, then now tell me at first how many digits are there in this particular number. Count the digits. So if I count the digits, it will be 3. Now find or sum of each digit with the exponent of 3. 3 here means the number of digits is called an Armstrong number. If okay, if this particular sum is equal to given number, then that number is called as an Armstrong number. Is called Armstrong number. I hope you got it. Okay, let me do something. Okay, so if you haven't got it, it's okay. Okay, still I will let you know. Okay, yeah. So let's say I have given you 1 2 3, right? Now how many digits are there? I can say digits equal to 3. 3 digits, right? 3. Now, so power, okay, so power 3 power 3, sorry, 1 in 1 power 3, okay, 1 power 3 plus 2 power 3 plus 3 power 3. Now sum up all of these values. Let's say 1 power 3 is 3 and 2 power 3 is 8. 3 power, sorry, 3 power 3 here, okay, sorry, 3 power 3 is 927. If you sum of all these, it will be something like 11 and 38. So is this 38 equal to the n which I have given? No, no, right? 38 is not equal to 123. So in that case, I can say that this is not a Armstrong number. Done. Now tell me you have understood or not what is Armstrong number. And the example for Armstrong number will be I guess yeah, cool. The example of Armstrong number is, yeah, I found one number. Okay, let's see the number. Yes, Kishore, hi. So let's say I have given you 153. Now tell me whether this particular number is an Armstrong number or not. Okay, how can you find? First you need to find the number of digits. So the digits here were 3. Now what you need to do? You need to sum up all the digits with the power of 3. Hi Shraddha. So 1 power 3 plus 5 power 3 plus 3 power 3. Okay, if I sum up all these values, it will be 3 1 plus 125 plus 27. Now it's a 153. Now I can say that 153 is a Armstrong number. So done. Now let's try to code this up. Okay, so here in this particular logic, you know how to find the number of digits, right? So we have done this problem yesterday. Okay, and you know here how to this as well. Okay, here what we are doing, we are each time we are taking the one digit, okay, which you know already, and for that particular digit we are just doing power of 3 and we are adding the sum, whole sum, that's it, right? So now let's say go, okay, and let's say I have given you 153. Okay, now give me a minute. Now let's create a temp. Okay, so because at first while finding the number of digits will make our n is equal to 0, right? So that if we store the copy of n, then it will be useful for us in the future. Okay, copy n is equal to n. Okay, done. Now first what you need to do, so first find the number of digits. So how can you do that? So it is very simple, right? We have done this. So and each time n is equal to n floor division by 10. Okay, while doing that we are keeping track of how many times we are doing this operation, so that yeah, so done. So in this note, I can say that we found the how many number of digits were there in the given number. Now what you need to do? Now you need to extract the each digit, and you need to power that with the number of digit, and then you need to sum up, right? So let's say I will say sum of numbers. Okay, sum of number equal to initially 0. Now the same task, right? So this time you are making your attempt, okay, your temp greater than 0. Okay, sorry, not temp, this is copy of n, right? Yeah, copy of n, copy of n. So each time first you need a digit. Okay, digit equal to, what is that digit? Here it will be copy of n mod 10. So these are, you are getting the last number. Okay, one digit. Now what you need to do? You need to sum of number plus equal to the digit over count digit, right? Count digit. That's it. Now you need to reduce your copy of n is equal to copy of n divided by 10. Done. So let's say we are done with this. So hope you have understood. Okay, if you haven't, please let me know in the chat. Okay, I don't hesitate to repeat the again. Okay, so please let me know in the chat. And here we need to check whether if here we have made an copy is equal to n as well. So let's after piece of work, let's say we'll keep that n again to the copy of n. Okay, so if our n double equal to sum of digits, sum of number, then it is a, let's say, given number is a Armstrong number, else not a Armstrong number. Done. Yes, Shraddha. Yes. So let's say, so what is happening at this piece of code? So I will, let me take a screenshot. Okay. Yeah. So here, let's see. Yeah. So here initially our n is, initially n is 153. Yes, initially n is 153. Now the copy of n is serving as n. So it is again 153. So here 153, here 153. Now this particular piece of code is doing finding the digits. Okay. So at the end of the day, you will have your count of digits in the count digits, right? So if I give 153, then what you will be having in count of digits? I hope you will understand this count digits, right? Since we have solved this, and I guess you are there while discussing the count digits as well. So it will have 3. So till now, do you have any doubt? Till now, do you have any doubt? Till now. So I guess you won't have any doubts. Okay. So let's see now what we are doing. So again, whatever the value, okay, here this n will be overridden to the this n will get overridden to the 0 after all these transaction. Now again I am keeping the n as it is. So I am storing copy of n into the n. Okay, so I can assume that again in n we have 153. So done. So now let's say we need to this piece of code, this particular piece of code helps us to a sum sum of exponent of count digit of each digit. Okay, let's trace this out. Okay, no worries, let's trace this out. Let's say sum of number, so initially it is 0. Okay, and the copy of n is 153. Okay, now so digit, we have digit here. Okay, we have digit. Okay, let me take another color. Yeah, so a digit here. So currently now we have entered into this loop. Yes, so copy of n is greater than 0. Yes, that is true. Now digit will become 3, right? Digit will become 3. So here what we are doing? So here we are doing sum of number plus. So as of now in sum we have the 0, right? Okay, 0 plus what is a digit? So 3. So 3 in 3 power. So you know, right, this double asterisk helps us to find the exponent. Okay, exponent, it means that exponent. So if you write this like 3 double into 10, then it would be 3 power 10. Okay, this is something like this. Okay, hope you got it. Now if here it means that 3 power 3. What is the value of 3 power 3? Can I say that it is 3? Sorry, it is 9. Okay, if you add this 9 to the sum, then your sum will become 9. Done. As of now you understood. Okay, now let's go back again. Okay, so here we are doing a copy is equal to copy by 10. Okay, now your copy of this if you do by 10, it will become 15, right? So now we are done with your first iteration. So please let me know if you are still confused. Okay, now let's go and check out the next iteration. So here the copy of n is 15. So still it is greater than 0, right? Still it is greater than 0. Now we'll go, and now digit is equal to copy 10 mod 10. Sorry, mod 10. Now your then it digit will be having 5. Your digit will have 5. Your digit will have 5. Now you will be doing digit power count digits. So your count digits is 3, but your digit is 5. So 5 power 3. 5 power 3 is 125. Okay, and what you are doing? So you are adding this 125 to the sum of numbers. What is the sum of numbers? It's a, sorry, here 3 power 3 is 27, right? Sorry. 3 power 3 is 27, sorry. Yeah, sorry. So 3 power 3 is earlier, 3 power 3, right? It's a 27. So if you add this 125 with the 120, sorry, if you add this 125 with the 27, it will become 152. Done. Done. You have understood. Now let's go and try for another. Okay, here then your copy of n will become again, it will reduce it to 1. So still 1 is greater than 0, right? So now we will again enter into this loop, and now our digit will become 1. Okay, so sum of digits, so digit power 3. Okay, it's a 1. Okay, if you add 1 to the 152, it will become 153. Done with this. Now what? Now you will be making your copy is equal to copy by 10. So if you divide it by 1 by 10, then it will become 0. So is this 0 greater than 0? No, it fails, right? It fails. Okay, so you will stop. Okay, you will stop. Now you will come here. Okay, you will come out of this particular loop and you will check. So in n, what you will be having? 153. In sum of numbers, what you will be having? 153. Is this both are equal? Yes, equal, right? So you can say that it is a Armstrong number. Done. Hope you have understood. So please let me know if you still haven't understood. Okay, I'm more than happy to explain it again. Yes. Yep. Yep, cool, fine. So please copy this code, okay? So like write it on somewhere, or if you wish to code, just make sure that you code it well. And then let's move on to the next problem. Okay, let's move on to the next problem. So the problem is pretty simple. Okay, I will be giving you a list. Okay, I will be giving you a list, and if you have any other programming experience, like you can assume that as a array as well. Okay, I will be giving you a set of integers, okay, which contains both a negative and positive numbers. Okay, let's see. So you will be having 10 comma minus 1 comma 5 comma 2 comma 60 comma 15 comma minus 3. Okay, so I will be giving you this list as your input, and I am expecting output as the minimum number out of this list. What is the minimum number in this particular list? What is the minimum number? I can say that it's a minus 3. Yes, I can say that it's a minus 3. So now how can we code this? Okay, how can we write code for this approach? And if you have anything in your mind, please let me know in the chat. Okay, so if no, it's okay, I'm there. Okay, I will explain it well. So let's see. Yeah, so here we will be making let's say a number as like variable as mini. Okay, variable as mini. Yeah, so let's make a variable as mini, and I am initializing this mini to the very first number in the list. What is the very first number in the list? It's a 10. Okay, it's a 10. Now what I will do now, I will take out this list. Okay, I will take out this list. Sorry, does it got stuck? Yeah, yes. Now now I will take out this list. Now I will check, I will go to each number. Okay, I will go to each number and I will compare it with the mini. Okay, so if my mini is greater than my number which I am currently standing, then I will be swapping the numbers. Okay, like I will be storing my current standing number in my mini. Okay, let's see, let's start at the 10. Okay, so first we are standing at the 10. Now tell me, is this 10 greater than the 10? Is this 10 greater than 10? No. So 10 is not greater, sorry, small. Yeah. So yeah, so this 10 is smaller than this 10? No. Which is no, right? 10 is greater than. So we don't do anything, we just go to the next element. Okay, now is this minus 1 less than 10? Like minus 1 less than mini? The condition is always less of I less than mini. Is this true? Is this true? Yes, yes. So minus 1 is less than 10. So I will store minus 1 in the mini. Done. Now I will go to the next element. Okay, which is 5. Now tell me, is this 5 less than minus 1? No, right? 5 less than, not less than minus 5. Sorry, minus 1. So I won't do anything. I will just simply go to the next guy. So now 2. 2 less than minus 1? No, again it's a false. So I won't do anything. I will go to the next element. Now 60 less than minus 1? No. 60 is not less than minus 1. Now 15 less than minus 1? No, again. Is now minus 3 less than minus 1? Tell me, minus 3 less than minus 1? Yes, minus 3 is the less. So what we need to do? We need to make our mini as minus 3. Done. So is there anything to traverse out after minus 3? No. So I will come out of the loop and I will print my mini. So if I print my mini, I will get minus 3 as my output. Yes, got it everyone? How we are doing? So let's go and let's quickly code this up. Did I executed this code? No, right? Okay, let's execute this code. Yeah, yeah, I got a given number is Armstrong. So did I hard coded this? Yeah. I hard coded this. So if I change it to the another number 1 2 3 or something like this, and let's see, yeah, it's a not a Armstrong. Okay, it works. So now let's erase all this piece of code. Now let's take a list. Okay, so you guys know how to accept a list from the user, right? For x in input dot split, that's it. Okay, you can mention here enter a series of numbers separated by space. Okay, this is just an like your wish. Okay, so whatever you are enclosing in between these double quotes, you can, it's your wish, either you can put it or not put it, it's your wish. Okay, so I am storing my mini and I will be putting my the first index. Okay, the whatever the element I have in my in my list, then I am storing in my mini. Okay, and then I am traversing to the all the numbers in the list. Okay, and I will compare if num less than mini. So if that particular number is less than mini, then what I need to do, I need to override that mini with the number. That's it. So after coming back, if um, if I print mini smallest number among all elements, then it's going to be mini. Done. So let's execute this code. Okay, and it is asking for enter a series of numbers separated by space. Okay, so yes, Shraddha, I will talk. Okay, so I hope you were not there. Okay, so a split is used to split the numbers. Okay, so you will see. Okay, so here I am saying that enter the numbers separated by the space. Okay, let's say I will enter 10 space minus 1 2 minus 3 4 5 and 2 again and minus 5. Okay, so here I am entering the numbers with the space separated by space, and if I hit that enter, so you can see that let's say, let's print. Okay, print a given input list. Okay, so now let's see. Okay, so what you got, like I gave this series of number and that number has been converted to the split. So I will tell you, okay, in depth how it works. Okay, so first, you know this input, right? You know this input, right? Now let's assume by default input will accept everything in the string format, so it will take out all these series. Okay, it will take out all these numbers and it includes spaces as well. Now you are telling that split the numbers by the space. Okay, so here you can see we have one space, here we have some space, here we have some space, right? So it will divide the numbers with the spaces. Okay, then you are taking, so you know what this for x in will do, right? So it will take out the each number over there. Okay, each number over there, and you know that again, and everything here are string type, so you need to convert that into the integer, right? So that is what you are doing. Okay, and you are storing that in the result. Yes, a list type. So if you say, so split it by comma. Okay, okay, split it by a series of numbers separated by comma. Okay, comma. Let's say now let's execute this piece. Now let's say 10 comma 2 comma 1 comma 3 comma 15 comma again 10 minus 1. Okay, so now I have given space like comma separated by comma. Now if I enter hit, now again what happened? So if I say if I split this input by hash, okay, now I am giving the numbers separated by hash. Okay, so 10 hash 12 hash 1. Okay, 10 hash 12 hash 1. Okay, now if I do that, now what happened? So I got the list in 10 comma 12 comma 1. Okay, so this is how it will help you. Yep. Now let's say if you wanted to find the maximum number in a list, what you need to do? If you wanted to find the maximum number in a list, what are all the changes you need to do in this particular code, in this particular code? So what are all the changes that you need to do in this particular code? So can I say that if you are able to change this particular symbol, instead of checking whether number is minimum than mini, if you check member is greater than mini, so if what, so you are showing something in mini, okay, and let's say let's change this to maxi. Okay, maxi. Okay, maxi. So here as well, yeah, we will get something here actually. Yeah, so maxi. So power of id. Okay. So here what I am doing, so earlier whenever I am saying that my number is less than mini, store the mini. Okay, now I am saying that whenever my number is greater than max, what I have seen till now, store that. That's it. Okay, store that. That's it. Now if I execute this code, so divided by hash, right? So 60. Okay, now I have given 10 comma 12 comma 60 and I got the maximum among all the numbers is 60. Okay, done. Got it. How we did this. So let's jump to the another problem. Okay, hope you have understood, right? Yeah. So basically there is a 20 minutes 20 seconds lag, so hope you got it figured out. Okay, so that's why there is a lag in replaying a chat. Okay, but I will sure I will be always keeping eye on chat. Okay, will definitely replay you back. So now let's go and code another problem. Okay, now yeah. Okay, search a given number is present in the list or array. Okay, so here again I am giving you input list. Okay, input list, and I am also giving you a target. Okay, I'm giving you target. Okay, target, so which is an integer type. This is an integer type. Okay, this is a integer list, int of list. Okay, now what I'm expecting is, let's say I have given you a list something like this: 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7. Okay, so here I have given in sorted order, but I might give you in a unsorted order as well. So yeah, you need to look in you need to consider both cases, and I am giving you a target. Okay, so let's say target I have given is 6. Now tell me whether a 6 is present or not. If it is present, just return me the index number where it is present. Okay, let's say my 6 here is at here. Now what is the index of 6? 0 1 2 3 4 5 6. Now 6. So at the fifth index 6 is present. Okay, if I give my target as 10, So is my 10 present in the given list? Is 10 present in the given list? No, right? So in that case, you need to return -1. Okay, you need to return -1, or uh, mm, let's say something like element not found. Element not found. Something like that. Okay. So please let me know whether you got this question or not. Okay. Whether you have understood this question or not. Yes, yeah, Shraddha got this. Okay, so very quick, yeah, because we have solved this a plenty amount of time. That's why. Shraddha, don't use that. Okay, for high in list. So you use the range. Okay, use the range concept and try to solve this problem. So yeah, don't take the advantage of Python here, because interviews will be asking you in general. Okay, so don't take the advantage of Python here. Okay, so you know range concept, right? You know range concept, right? So forgot. Okay, so try to solve that using range concept. So let's say, so how can you find? So let's say index is equal to initially -1. Okay, I'm storing index initially -1. Then for I in the range of, how many times we need to iterate in a loop? Can I say the number of elements present in the list? I need to iterate that many times. Yes. Yes. So then for that I need the length of the list. So this will help that. Done. Yes, got it. Right. Now what we need to do? We need to check whether ls of I equal to target. So here we don't have target. Okay, so we need to accept that from the user. So target equal to int of input, enter a number. Cool. So now, so whenever this particular L of I double equal to target, which I'm finding, then what I can say? I can say that print, okay, I found the target at, okay, so here I can say index. So you really don't need index as well. So I can say it's an I, sorry, it's an I. Okay, it's an I, and you need to put it as a format. Sorry. Yes, done. And now tell me whether I need to check with the rest of the elements or not. Whether I need to check with the rest of the elements. No, right? So I found the guy. Then I don't need to check with the rest of the guys. So what I can do? I can simply break out of the loop. So I can simply break out of this. So let's say break. Break. So here instead of like simply returning, I will be storing index equal to I. Okay, index equal to I. So now let's see why. So whenever we found a guy, we are telling that we found the guy at ith. Okay, that's fine. So what if I didn't find a guy? Okay, I didn't find the target in my entire list. Now this piece of code will never execute, right? This piece of code will never execute. In that scenario, what will be my index? It will be -1 for sure every time. So whenever my control never entered into this particular 3 lines, I can say that my code, my index is going to be -1. So I will come out of the loop and I will check. Okay, I will check if, sorry, if index double equal to -1. So if index equal to double equal to -1, then what does it mean? It means that I never entered into this piece of code. Okay, I never entered into this piece of code. If I never entered into this piece of code, it means that I haven't found the guy. Okay, I haven't found the target. Right, done, done, understood. Yes, you can use simply flag as well. Okay, yeah, you are using this index like ind as a flag here. Okay, by indirectly. Okay, let's execute this. Okay, so separated by, again split by. Okay, like I will stop this. Okay, yeah, every time giving this thing. So now you got why, how split functions, right? Shraddha, so tell me, so are we making index of -1 any by any chance? Like, is our I is going to be -1 at any chance in this loop? In this loop. So that will be the answer for your question. That will be answer for your question. So let's say 10, 5, 6, 20, now I want a number for target. Okay, let's give target as a 9. Okay, so if I give target as a 9, then what should be my answer? Not, I haven't found. I haven't found. So yes, I haven't found the guy because 9 is not there in this list. Okay, if I execute this again, let's say I have been giving you 1, 2, 3, 4, and 100. Okay, and if I give my number as 6, okay, if I give my number as 6, then my answer should be 0, 1, 2, 3, 4, 5, 6. Okay, sixth index. Okay, I found the guy at 6th. Okay, let's put index. And hope you have understood. Hope you have understood. Now let's modify this particular question little bit. Okay, little bit. So let's say I will be giving you a list. Okay, again I will be giving you a list. Now you need to find, okay, and I will be giving a list and the target as well. List and target same as of now, and you need to find how many times that target has been occurred in the list. Okay, so you need to count the occurrences of a given number in a list. Hope you let me know whether you have understood the problem or not. Okay, let me know. And if you understood the problem, let's go and make the changes and let me find. Okay, so what are all the changes that we need to do in this piece of code? Okay, in this piece of code, so here we don't need this statement. Okay, we don't need this statement as well. Okay, and we don't need to break, we need to check the entire list, right? So now, so whenever I found an element, okay, so I don't need this as well. Okay, all I need is an count variable, count occurrence. Okay, count occurrence equal to initially 0. Okay, now whenever my ls of I equal to target, whenever my ls of I equal to target, then what I need to do? I need to simply increase my occurrence by 1. Yes, yes, just let me whether you have understood or not. Okay, and after coming back, if I print total number of times um, target occurred in the list is count digit. Okay, count occurrence. Yes, done. So now let's go and execute this code. Okay, now I will be giving an input like 1 1 1 2 2 2 3 3 3 3 4 4. Okay, now I am giving my number as 5. Okay, I am giving my number as let's say first let's give 3. Okay, let's give 3. Now if I give 3, I will be expecting 4 as my answer. Okay, I will be expecting 4 as my count. Yes, I got the 4. Now I will be giving a next time. So okay, now I will be giving you number as 6. Okay, I will be giving you number as 6. Now how many times 6 has repeated in the given input? It should be 0. Yes, 0. Fine, this is what we wanted. Yes, got it. Please let me know whether you got this or not. Yes, okay, let's go and solve another problem. So this time the problem statement would be okay, sum of first n natural numbers. Sum of first n natural numbers. Okay, how can we do that? Sum of first n natural numbers. Okay, sum of n first natural numbers. And sum of first n natural numbers. How can we do that? How can we do that? Hey, yeah, we have solved this. Okay, we have solved this problem. All you need to do is one change. Okay, so let's say I will be storing sum of n. Okay, sum of n is equal to 0 initially. Now what I need to do? I need to generate the numbers from 1 to n. Yes, I need to sum up all the numbers from 1 to n. How can I generate that sequence? Okay, so how can I say for I in range of 1 comma n plus 1 1, that's it. Yes, done. So understood why we have written our range like this. Okay, now what I need to do? I need to do sum of n is equal to I. So if I print my sum of n, then that would be answer. That would be answer. That would be answer. Execute it. If I give my answer as 10, the sum of first 10 natural numbers is 55. Yes, I got 55. So is there anything better that we can do? Is there anything better that we can do? Let's say let's take the time complexity. Okay, how to calculate time complexity here? Okay, so that is very important to accept. So let's say okay. Okay, so now tell me how many times this particular statement is being executed. How many times this sum of n, okay, this statement is executed. So let's say my n is 10. Now tell me how many times this statement will get executed. Yes, Shraddha. So yeah, it's okay. Okay, you know formula, that's okay, fine. Okay, you know formula, that's okay, fine. But you need to understand the concept of time complexity here. Okay, how much time we are saving. okay, with the formulas. That's the important thing that one has to understand. Okay, so here now tell me, if I give my n is equal to 10, how many times this particular statement will get executed? Yes, yeah, that is right answer. Okay, okay, cool. So 10 times, I can say 10 times. Now if I give my n is equal to 1000, now how many times it will get executed? 1000 times. If I give my n is equal to 10 power 10, will it get executed? Like it will make 10 power 10 times. Okay, so basically our computer won't process for this much of time. Okay, our computer won't process the things for this much of time. Okay, so basically we will be having only 1 second of time to execute our code. 1 second, only 1 second. So in that particular 1 second, we can execute only 10 power 8. Okay, we can execute only 10 power 8 statements. Okay, 10 power 8 statements. Now tell me, will this 10 power 10 executed in this particular code? We won't get an output. It will give us some timeout error. Okay, I was unable to process your request in the 1 second. So here the one thing that we need to understand here is we need to reduce our time complexity. Okay, for that whenever there is a possibility of using formulas, okay, we can use that. So you know, right, you are not a kid. Okay, so in school, okay, in schools, let's say I have asked the same question. Sum of find the sum of first 10 digits. Now you started doing 1 plus 2 plus 3 plus 4 plus 5 plus some kind of thing. Okay, and I have given you 100. Okay, 100 as a my n. Now how much time will you take? At max will you take 5 minutes? At max will you take 5 minutes? Right? So instead of this, if you use formulae, instead of this, if you use formulae, now how much time that you are going to take to solve this particular problem? Can I say it is not more than 1 minute? It is simply n into n plus 1 by 2. That's it. So here the amount of time that you are taking to solve the problem is very important sometimes. Okay, that's why we have the we measure the algorithms with the time complexities. Okay, if the time complexity of a given algorithm is very less, then that's a good solution. Okay, if the time complexity of the particular solution is very big, then that's an worst solution. We need to reduce that thing. Okay, and I can give you the real life scenario as well. Okay, let's say if you are ordering, I hope you guys have ordered something on Amazon. Okay, let's say you are making a payment. Okay, you are making a payment and your payment took 1 minute of time. Your payment took 1 minute of time. Now what will be the your situation? Okay, what do you think? So yes, 1 minute. Okay, so did my payment got cancelled? Did my amount got debited from my account? Will it Amazon will place my order or not? So you will think of these kind of things. So now just imagine if your payment got succeeded in the 5 seconds or 2 seconds or 3 seconds. 3 seconds. Now you will be happy. You will be happy, right? This is where in real world, okay, companies invest very huge amount of money to save the time, okay, to give the best experience to the users, right? So that's what a time complexity means. That is the use case of time complexity. So now tell me, so for this particular solution, what will be the efficient answer? Use formulae. So sum of n equal to n into n plus 1 by 2. That's it. Hope you got it right. Understood why time complexity is very important. Why time complexity is important. Okay, so think like a missions. Okay, that is the reason. Think like a missions. Sorry, think like a human being. Okay, think like a general common man and act like a robot. Okay, think like a human being, act like a machine. So execute n times for a current situation, and if we use the formula, then constant time. Yes, Shraddha. So we are executing the statement only once. Okay, how much big a number is, we are executing the number only for one time, right? So there is a lot of difference between 10 power 10 and 1, right? You know the thing. Okay, so let's replace the piece of code with the, yes, your thinking is correct. Okay, your thinking is correct. So here, how can we write that? So let's make, so n into n plus 1, you need to whole divided by 2. So let's see how many times this particular statement will get executed now. Only one time. How much big n is, it will get only executed for n one time. Okay, let's say our enter number is 100. Okay, we got 5050. Okay, so I can show you the difference as well. Okay, I can show you the difference. Okay, let's stick to the previous code. Okay, let's stick to the previous code. Let me write that. Okay, for I in a range of n plus 1, okay, so here I will be let's give 10 power 10 or something big than so like let's say I have given you, I was unable to count the numbers, but it is something greater, right? Which is something greater. So let's enter. So it is taking a lot of time. It is taking a lot of time. So let's wait for that time, and let's at the end, let's see what it will give us. So if you think it will take it will gonna take definitely 1 year time. 1 year, I guess. Yeah. Okay, it will gonna take 1 year or something. Okay. So it's very simple, Shraddha. It's very simple. Okay. It's very simple. So usually you will write the, so what is the thing that you haven't understood, Shraddha? What is the thing that you haven't understood? What is the thing that you haven't understood? What is that thing? So here something, so it gonna it is not gonna execute in this particular session. Okay, so if you come after 1 year, it will get executed. I don't think it will executed in 1 year as well. Okay, so I have to stop this. Okay, I will stop this here. I will tell you the fact. Okay, I will tell you the fact. So basically, if you are giving 10 power 18, okay, if you are giving 10 power 18, then it will take 35 or 34 years, I guess. 34 years to execute that particular statement. Yes, 20 seconds delay. 20 seconds delay. So that's very common in every stream. Sorry for that. So if you give 10 power 18 number, then it is gonna take 34 years to execute. That's why while solving computer, like while solving problems, okay, while solving problems, it's very the thing, like they won't give you that much of time. They will give you only 1 second of time if you are submitting any question on code chef, code forces, or something like that. Okay, so if you wanna see that, I can show you. Okay, so hope you have seen that particular thing as of now, right? So I was saying it will execute once if we use formula. Yes, yes, at once, at once. So it's like number of times that particular statement is executing. Okay, so if you are iterating for the n times, then it will gonna execute for n times. If you are writing it in singular time, then it's gonna execute in single time. That's it. Okay, so we will be having a session, separate session. Okay, so how to compute the different time complexities. Okay, so we will do that. Okay, we will do that. That's very very important before starting data structures and algorithms. Okay, we will do that as well as a separate session. But as of now, you understood, right, importance of time complexity in real world and in programming as well. Okay, that's why so whenever you see any problem on online, they will give you the constraints as well. Okay, they will give you the constraints like you need the max length of n will be 10 power 18, 10 power 8. The max length of n will be 10 power 5. The max length of n will be 10 power 3, something like that, right? Okay, so luckily Python has some more features than any other programs. Okay, yeah, there is something like space complexity as well, so we'll discuss that in further sessions. Okay, it will get overwhelmed, okay, if I discuss more, but as of now you have understood everything, right? So that's the end for this particular session. Hope you have learned a lot in this session. Hope you have learned a lot in this session. So if you want to know the such a fact, like so like why Vamsi is saying it's gonna take 34 years. Okay, so if you want to know, no, so just go and Google that. Okay, how much time it will take to compute 10 power 18 in one program. Okay, so how many data structures are there in Python? I know list, tuple, data structure. Yes, so basically they list, set, tuple, set and dictionary are the data types in the this Python, but they were not exactly the data type. Okay, data structures. Okay, data structures. So there is something like linked list, trees, graphs. Okay, stacks, queues. So we will be seeing all of them as well. Okay, so cool. So these were the real data structures like stacks, queues, linked list, trees, graphs. They were the real data structures. This list, tuple, set, dictionary are the not the real data structures. But in Python, we use them as a data structures because they provide that functionalities. Okay, whatever the functionalities our real data structures provide, we can implement them using list, tuple, set in dictionary in our Python. So that's why we are calling them data structures in Python. Okay, so yeah, so yeah, don't rely on them as a data structures. Okay, you need to explore more. Okay, you need to explore things like stacks, queues, other stuff. Okay, we'll have a separate session. Okay, we'll have a separate session where we will be discussing more about data structures and what are all the available data structures and all. Okay, and we'll try to implement them in Python as well. Okay, cool. All those were discussed after oops. Okay, oops are the first, then data structures, then DSA. Done. So yeah, thanks guys. So let's see you. Yeah, these are the data types. Akka data structures in Python, okay, but they were not the actual data structures. If you go and talk with any C++ people, like who code in C++, so if you tell list, tuple, set and dictionary as your data structures, they will laugh at you. So, hey, no, what are these? I never heard of those data structures. Okay, all I know is stacks, queues, linked list, trees, graphs, and all. Okay, so yeah, it's even if you are attending a product-based interviews, interview will keep mind will ask questions by keeping in mind data structures as an original one. Okay, not the one in this particular list tuple. Okay, yes. Okay guys, so okay, bye bye, see you tomorrow.